All right, guys, good morning. Right now when I'm recording this, it's Friday, so hopefully you had a good weekend. But as you're watching this, it's Monday. I'm at a meeting, actually, for your class. But you guys still have some good work to do today, so let's get to it. Now, a couple things first. I've already messed up a few times trying to record this, so hopefully third time's a charm. As we go, I'm going to give some instructions, and I may need you to pause the video every once in a while, maybe to have some think time, or to get materials, or to kind of get set up, or to discuss for a second. So when I do that, instead of creating a bunch of different small videos, when I say to, either one of you guys can volunteer, or the substitute teacher, if they would like to, I'll say pause the video, and I'll hold up this sign that says pause video. And when I do that, pause it for however long I said, or however long it takes you to get ready. And then when you're ready, unpause and we'll keep going, all right? So, here's your do now for today. Just take about 10 seconds for these two questions on the bottom. You do not need to write anything down today. So take about 10 seconds. Five, four, three, two, one. All right. Now, this is still class. You know what we do at the start of class every time. So, take this time, press pause, and go ahead and check in. Great check-in, you guys. I'm proud of you for doing that, right? It's good to check in every morning with each other, especially on a Monday. All right. You notice today we're still dealing with expressions. We're actually almost to the end of Unit 1. We're going to use the rule of 4 today with our expressions, right? It's on that poster on the back wall. Pictures, words, equations, tables. Equations or expressions, right? Algebra. So our agenda is this. We're going to do a couple examples together, one of them from your exit ticket from last time that a couple of us still weren't quite getting. And then I have a worksheet for you guys to do to get started. I'll give you maybe 15 minutes or so to work on that. We'll come back together, check answers, and then I'll give you directions for your task today, card sorting task. I want you to be in groups of 2 or 3. You can pick your own groups. I'll mention that again later. It is graded. This will go in the grade book for a grade. You turn it in end of class, end of period. And we have a quiz on Wednesday, our Unit 1 quiz. Friday, we're kind of going to be doing a bridge between Unit 1 and Unit 2 with one other kind of card sorting-ish type of task. I think it's pretty fun. So quiz Wednesday. Let's get going. So let me bring this over here. Okay, first of all, guys, come on. Let me show you this picture. Take a nice look. Yes, this is from our room. This section here is my freshman Algebra 1 class. Notice the contrast. This is my senior Bridge to College math class. You guys. Come on. We need to step it up. That's trash. Like, I don't want that disorganization in my class. Like, take pride in your work. Remember that poster we have over on the wall over there? What does college-ready work like? I think the second thing we have on there, is organized. So let's be a little more organized when we put our stuff away today. And actually, you don't need your binders today. So if you have them, great job for getting them out. Keep them for now. Put them away nicely at the end. All right? Okay. I want to do just a couple examples together just to get the conversation going. And you don't have to write these down unless you want to. You can just listen and think, process as we go. Your exit ticket from last time was this. It was, are these, something like this. Are these two things equivalent? I had several people say yes. Several people say no. The correct answer is no. They're not the same. They're not the same. But why not? That's what's more important. Why not? For the people who said they were the same, they said something like, oh, well, if you distribute the 2, then that would give you a squared plus b squared. Okay, yeah, correct, if you distribute. But distribute means multiply, not, it does not mean exponent, right? Like, when you distribute, that's when you're multiplying through a parentheses, not taking care of an exponent that's out there. So that was the most common reason that was given for people who did it wrong. For people who did it correctly, there was a lot of different explanations. The correct mathematics, the correct work for it, is like this. A plus b squared, remember, squared means times itself, right? Times itself. So it's this thing times itself. Times itself. Now, some people even just stopped right here and said, well, this isn't going to become a squared plus b squared, so they're not the same. That's a great answer. But let's take it a step further and show why. Like, you guys know how to do that distributive property, that F word that we don't say in this class. FOIL. Don't say that. How dare I need to put a nickel in the swear jar. You distribute, right? A times A squared. A times B, AB. B times A, well, BA. Same thing as AB, though. And then last times last, b squared. And if we simplify, you got a squared plus 2ab's. Remember, like we just said, those are the same thing. You can move them around, switch spots, and add them together. Plus b squared, right? This part here is not the same as this up here. So they're not equivalent. All right? A couple more. And this is going to be, I don't know why I drew a line here. This is going to be related to what your task, your card sorting task will be today. So let's pick another one. Let's do this last one I have here in my examples. 5 parentheses 2x plus 3y plus z. All right. Now, we looked at last time, I had you guys do a couple tasks really fast using the area model, where you take one term and set it as like the side length of a side of a rectangle, and you set these terms as part of the other side of that rectangle, 2x, 3y, and z. Right? So we kind of made a visual representation of this problem. Area, when you find area, right, you use multiplication. Length times width, right? And this problem, I wish I could point at this screen. This problem here, that's multiplication going on right there. Like length times width here. So we can represent it visually by thinking of area. Now, since this has 3 terms, let's make 3 sections. The area of this first section, well, it's 5 times 2x, or 10x. The area of this second section is 5 times 3y, or 15y. And the last one is 5z. Now, you'd get the same terms if you distributed like this, but I like the visual representation sometimes. Both answers will be the same. 10x plus 15y, plus 5z. Okay? So I want you to be thinking about this multiplication, ways expressions can be equivalent. That's what we're going to need for our task today. Now, either substitute teacher, I need you to hand something out, or you can give it to a student to hand out. I don't know why I keep looking over here as if someone's sitting over there. You should have this handout. All right? As you get that out, let's look at the time. Let's say about 15 minutes. I'll write it up here. 15 minutes. Take about 15 minutes on your own or with your group and complete this worksheet as a little precursor to our task today, all right? So 15 minutes, you may pause the video and begin work now. All right, hopefully it's been 15 minutes. Hopefully you guys got some good work done. Let's go through these answers really quick because my video time is going a bit long. The first one, write an algebraic expression. So do the math for it. Well, multiply n by 5 and then add 4. We've done this before. 5n plus 4. Add 4 to n and then multiply by 5. We'll add 4 to n and then, right? Remember the and then gave us parentheses and then multiply by 5. These two look very similar, but they don't mean, they're not equivalent. Not equivalent. Add 4 to n and then divide by 5. So add 4 to n and then parentheses divide by 5. Let's see, multiply n by n and then multiply by 3. Well, n by 3. I don't like how that looks, right? We usually write it a different way. N squared times 3. Let's see. E says multiply n by 3 and then square the result. Ooh, this is different, right? Multiply n by 3 and then square that. That would not be the same. These are not equivalent. They're not the same. This one would actually be 9n squared. 9n squared. All right, let's keep going. The equations below were created by students to write equivalent expressions on either side of the equal sign. Oh, we're starting to get with equations. Imagine you're the teacher. Your job is to decide if their work is right or wrong. If you see an equation that is false, then cross it out and write the correct one on the other side. Explain. I don't have time to explain. Let's just see if we're on the right track and we'll talk about it. See if our talking matches the explaining, okay? First one. I hope these are not the same, right? When you distribute, 2 times 3 is not 3, so no, not equal. This should be 2n plus 6, right? You could use that area model if you wanted to do that. 10n minus 5 is equal to this. Are those the same? Yeah, they are. You divide both terms by 5. So 10n divided by 5 is 2n, and 5 divided by 5 is 1, and you got the minus sign in between. That one's good. Good job. Oh, this one's like the one we just did up top. These are not the same. 5n squared really means 5n times 5n. Well, 5 times 5 is 25. N times n is n squared. So no, they're not the same. That's what you should have. Last one. Oh, we got couple equal signs. Okay, this, no. We know that. That was our exit ticket from last time. You can't just distribute like that. Which means this is also not equivalent, right? Because all they did was take this and turn it into 9. So no, that one's wrong. Remember, this means the same thing times itself, which if you do that distributive property, n times n is n squared, you'd have 3n and a 3n or 6n when you add like terms. And then the last term is 9. So look what happens when you just distribute that term. You end up missing this middle term here. It's gone. So it's not equivalent then, right? They have to be the same thing. Okay. You need to be into groups of 2 or 3. This video is almost done. Get into groups of 2 or 3. New people is fine. Spread around the room. I'll see you guys in a bit. Groups of 2 or 3. Go.